lesson 2.2 is modeling with power functions. So one of our standards relates to being able to work with, I think it's recognize and write power functions. So we're going to talk about what a power function is. The big thing is going to be able to distinguish the difference between a power function and a monomial function. And so we're going to work with that. So definition of a power function is up there. F of x equals k times x to the a. Okay, that is your definition of a power function. Now, specifically, k and a are defined to be non-zero constants. So they can be 1, they can be anything else, they just cannot be 0. Okay? In a power function, a is considered the power. It's in the exponent, of course. K is what is called the constant of variation or constant of proportion. And you'll have to be able to identify those when we look at power functions in homework. A little bit of vocabulary or how it can be read. F of x varies as the 8th power of x, or in other words, the power of a. Okay, with that in mind. Similar, you'll notice I have an or over here. Or f of x is proportional to the a power of x. Okay? With that in mind, just the idea of what it means. This k is our constant of proportion or constant of variation. Okay? Independent variable is still x. And then this is relating back to direct and inverse variation, which you did a little bit in Algebra 1 and or Algebra 2. But power functions with positive powers are statements of direct variation. When you've seen direct variation in the past, you've probably seen it expressed as y equals k times x. Okay? Or f of x equals k times x. But if the power is positive, it's a direct variation. If the power is negative, it is an inverse variation. Because keep in mind, a negative power, what's a negative power going to do? It's going to take it to the denominator. Okay? So all of that is a little bit about power functions. We'll go down here and talk a little bit about power functions in example 2 about being able to identify the pieces. Oh, and I forgot. You would probably see this as written as y equals k divided by x. Okay. So let's look at example 1 here and go from there. From empirical evidence and the laws of physics, it has been found that the period of time t for the full swing of a pendulum varies directly as the square root of the pendulum's length L, provided that the swing is small relative to the length of the pendulum. Express this relationship as a power function. Okay, so basically, scenario here, we're going to use this to write a power function. So, I'm going to go back and get some key things. Let's see. The period of time, t, so we're going to use t for the period of time. For the full swing of a pendulum, key phrase here, varies directly as the square root of the pendulum's length, L, provided that the swing is small relative to the length of the pendulum. Okay. Our job is just to write an equation here. Okay? Write a power function, I should say. Thoughts on how to do this?
T times L.
No. And I guess one of my hints would be if you use this idea that f of x varies with the a power of x, or direct variation. When we had direct variation back in algebra, it was y varies directly with x. And anytime we say y varies directly with x, what does there have to be in there? some type of constant of variation, which is usually expressed as k. Okay, so in this one, the period of time t, what does it do?
It measures the full, or no, the period of time.
Period of time t.
Yeah.
But then what does it do? It's going to vary directly.
Yeah.
So right there, that's kind of like saying y varies directly with x. We're going to think t equals. When you see the word varies directly, varies proportionally, you need a constant of variation or a constant of proportion in there. What is our constant of variation or constant of proportion? K. So this is going to be the idea of k times whatever we need. So when we see varies directly, I'm going to say k, and it's be k times what? What is time varying directly with?
The length.
The length. There's a little bit of a catch there. Not just the length, but what?
The square root of the length.
The square root of the length. So square root of L. That's basically the power function, except if it's a power function, what's the key here? It's supposed to be in this form, k times x to some power a. We have k times the square root of L. How could I rewrite that?
K to the 1/2 power.
Not k to the 1/2, but yeah, k times L to the 1/2, because what do we remember about square roots? Square roots that can be written as the power of 1/2. Okay, so that's a scenario to write a power function there. Questions about the interpretation there?
No. Is that
Okay.
the whole answer?
That's the whole answer.
Oh, okay.
I know, kind of a big space for that. I don't know what I was thinking, but
How about it?
okay. A little bit more in example 2 about power functions. Okay. Here, it asks us to state the power and constant of variation for the following power functions. Remember, if it's a power function, it fits the form from up above of f of x equals k times x to the a, where k and a are non-zero constants. Okay. They're asking us for power and constants of variation. Thoughts on this first example? It's f of x equals the cube root of x. What's another way to write this?
No.
Or, I'll just jump right in here. They asked me for the power. What's the power? The what?
When you do it to the third.
Not to the third.
The 1/3.
1/3? Does this ring a bell here, folks? The cube root of x can be rewritten as what?
X to the 1/3.
X to the 1/3, because whatever that radical, whatever that root is, goes in the denominator. So since it was a cube root, that 3 goes in the denominator there. So f of x equals x to the 1/3. With that in mind, what is our power now?
1/3.
Yeah, in the position of a is 1/3. The other piece of information they're asked for is the constant. Okay. Sorry, BenQ kind of glitched. Constant of variation. And with a constant of variation, what do you think the constant of variation is here? In other words, what's in the position of k?
Okay. Okay.
What's in the position of k? No. It's a constant of variation, so it has to be a number. 1, right? In other words, what number is in front of x to the power?
Oh.
And that, in this case, is just an invisible 1. So k is 1. Okay? Let's look at B. G of x equals 2 over x squared. We need a power and a constant of variation. Thoughts on the power?
2 or x squared, whatever, or a equals 2.
Not exactly 2. Remember, if we're looking at the power, it has to be in this form. F of x equals k times x to the a.
-2.
Yeah. So, and I didn't have you guys.
I thought the constant variation.
No. So if we rewrite this, 2 divided by x squared is also 2 times x to the -2, yes? And so taking that out of the denominator, so we have x to some power. And so our power, I'm just going to write a, is the -2. And remember, the key is a, as long as it is non-zero. It can be anything other than 0. What is my constant of variation?
2.
That is the 2 out front. Okay? Thoughts on C? H of x equals -x to the -4/10.
Ours just negative 4.
Okay? Is it already in the right form?
Yeah.
It's already k times x to some power a. So there's no rewrite necessary. A is the power of -4/10. K is the -1 out front. And on all of these, folks, the idea here, notice my constant has just been a constant, but my power has been negative, it's been positive, it's been a fraction, it's been a decimal. All of these are options. Okay, D. M of x equals -3.
It's not a function.
Constant's -3.
What's the power then if constant's -3?
Undefined.
1.
Officially, this could be rewritten as
0.
-3 times x to the 0. That is an equivalent way to write this, yes? Because when you have x to the 0, anything raised to 0 is 1. Now, what's the power here in that scenario?
0.
The power is 0.
It
But
says where k and a are non-zero constants.
k and a are non-zero constants. So can a equal 0?
No.
No. So this is not a power function. So your one scenario of when it will not be a power function. Questions there? Okay, that is all about power function. Keep that definition straight. K times x to the a, k and a are non-zero constants. That's the key. K and a can't be 0. They can be anything else. Because now we're going to compare that with a monomial function. Okay? Monomial function is very similar, but it has just slight differences here. So a monomial function is defined to be either f of x equals k or f of x equals k times x to the n. Those are your two options there. Probably the more generic one to remember is k times x to the n. That's very similar to our power function, isn't it? It was K times X to the A, this is K times X to the N. What you have to pay attention to are the definitions. K is a constant, so that means K could be 0 this time, right? Positive, negative, fractions, whole numbers. Okay, K can be anything there. What's it say about N?
Positive. Positive.
A positive integer. So what do we mean about positive integer?
It's gotta be positive.
Okay, 0, 1, 2, 3, 4, so on and so forth. Or in other words, a whole number.
So 0
Okay.
counts.
0 does count here.
What if I consider 0 negative?
Well, we could go into that. We could go into that mathematical definition where 0 is neither negative nor positive, but
Don't find it.
the way they have it is 0 is included.
Exclusion only.
Okay. Now, okay, this is for a monomial function, so you have to be very careful there in noticing the differences. Okay, your integers have to be positive, or your power has to be a positive whole number, basically. Okay. Now, I just have one here with example 3. It asks us to state the degree, the coefficient, and the independent variable of the monomial function y equals negative 3x to the 5th. Let's start with degree. What do you guys remember? Degree is 5, right? Okay, it's another name for the power. So, okay, they asked for coefficient. Coefficient is negative 3. Okay. That is the number out front. I'm going to list it as K. And then the other piece they request is the independent variable.
Just X.
Yep. Independent variable is just what it would be, you know, what's the equation based on, okay? So this would be like an f of x equation. X is your input. That is your independent variable. If this was something and it was f of c, where c is your input, then c becomes your independent variable. Okay? Okay. The homework that goes with that is page 177, 1 through 22, and it is due tomorrow. Okay? Now, we do still have a homework to go back and check, though.
I was wondering how you guys did it.
No, we already did it actually.